Hello everyone, welcome to NS Academy. So today we are going to look at this question, and this is a question that will help you understand the general way of solving equations, polynomial equations, and also equations which has polynomial terms, but you have to simplify it to make it a polynomial. So in this question we are given n real numbers in some ordering, a1 less than a2 all the way up to an, and these are all positive reals, and we have to find out the number of real roots of this equation. So a1 upon a1 minus x plus a2 upon a2 minus x and plus all the way up to an by an minus x equals to 2015. So it's an equation of nth degree, that much is clear, and we have to find the number of real roots. So I'm going to show you one of the ways to approach such a question. If you are given such a question in any examination, I'm going to do it subjectively. Of course, objectively you can also do the same, but you just have to give the final answer. So what I'm going to do is this equation, I'm going to try and assume first, because I kind of understand what's going on here. So I will assume that this equation has all real roots. So what I'm going to do, I'm going to let x equals to p plus iq, where x is an imaginary root, and I will see what happens after that. Okay, let x equals to p plus iq be an imaginary root of this equation if there are any, and I will try and prove that this leads to a contradiction. So if you put in this, basically can be written as I equals to 1 to n ai by ai minus, this is p plus iq, because the root must satisfy the equation, correct? So this should be there. Now this should give you I equals to 1 to n ai. Now the conjugate of this is simply ai minus p plus iq, and here you will have, I think, ai minus p whole square, ai minus p whole square plus q square equals to 2015. This much is clear, correct? Okay, so now what we can do here is we can separate this into two parts. First of all, we are going to separate the real part, ai whole into ai minus p by ai minus p whole square plus q square. This is the real part, plus I into I equals to 1 to n. So this becomes ai into q divided by ai minus p whole square plus q square equals to 2015. Now looking at both sides, you can see that the right hand side is a real number, so this imaginary part must be 0. So if this imaginary part is 0, we can conclude that summation I equals to 1 to n, let the q be outside, ai divided by ai minus p whole square plus q square equals to 0. Now we all know these are positive reals, so ai is positive and this term is also positive, and like strictly positive. So the sum of strictly positive numbers cannot be 0, but it is given that the sum is 0. So obviously we must have q equals to 0. So we can conclude directly from here that q equals to 0, which means if x is an imaginary root, the imaginary part has to be 0, so x is a real number. So any root that it might have is all the n roots are basically real numbers, because even if it had an imaginary root, we proved that that imaginary root has a 0 imaginary part, which makes it a real number. So this is one of the ways you can approach this type of questions, and this type of questions are also very common in ISI CMI examinations and also in JEE Advanced, where you are asked to find the number of real roots. Okay, so I will bring more of these single questions so that you can understand and grasp a concept from one of these questions and apply it to your next examination. Thank you, and let me know in the comment section if you want anything else.